Hi everyone, this is the technical demonstration for Project Green. Project Green is the final capstone project created by Team Guapo for the 2020 graduating ITCS major here at St. Polytechnic. Team Guapo members include Daniel Belante, which is me, Jose Pantaleon, and John De Los Santos. Project Green is an automated lighting system which is aimed to help indoor plant growers automate their grow lights. Here I have the home page that users will first see when accessing the management webpage. What is shown here is called the Green Network, which is just a diagram of the network we have currently set up. You can see we have two lights on the right of the diagram, but each light is in a separate pod. In real life, these pods may be in different rooms and are therefore managed separately. To access each light, you must specify the pod number and the light number, which acts as an ID for each light. You can also see that each network is connected through a router and a firewall. For this we used pfSense, which is an open source firewall and router distribution. We configured a site-to-site VPN through each router to ensure that all network activity was encrypted and secured. Through the VPNs, we are able to communicate securely with the Raspberry Pis, which act as the control point for each pod. I will now let my colleague Jose explain how we are able to manually turn on each light.
Hey guys, this is Jose and I'll be going over how to manually control each light. In order to turn on a light, we will use the navigation section on the left to navigate to the manual page. Keep in mind the manual switch will override any auto schedule we have set up for the light previously. Once we go to the manual page, we must select the pod we want to access. In this case, we choose pod 1. After selecting our pod, we must choose the light we want to access. In our case, we only have one light in each pod, but in reality, we may have up to 8 lights in one pod. We select light 1 and we are brought to the switch page for pod 1 light 1, which allows us to switch this light on or off. By selecting on, we are brought to a web page located on the Raspberry Pi itself, which automatically executes the Python script needed to turn the light on. Now I should mention that because of COVID-19 and classes being transferred to online, we weren't able to access a lot of the hardware we were depending on for the project, including the Raspberry Pis and the lights. Therefore, we had to virtualize the Raspbian operating system and use different scripts to represent the actual scripts needed to turn a physical light on and off. The scripts we replace these with are very simple and only write to a text file if the light is on or off. And this way we are able to observe if the scripts executed or not. Here is some of the source code for our on and off scripts. You can see that the script actually does two things. First, it writes the information to a log file, which Daniel will talk about later, and the second, it writes on or off to a text file. In reality, we would be replacing this code with GPIO code, and in turn we would be manipulating a relay which would be turning the light on or off. We can see that this light is on by viewing our state.txt file, which simply says on. We can now go ahead and turn this light back off by going on our web page and selecting off. We can now go back to the Raspberry Pi and see that the state of this light is set to off. I will now let my colleague John explain how the auto scheduling feature works.
Hello everyone, this is John and I will be going over how to schedule a future time for the light to turn on or off. Just like before, we will use the navigation section on the left to navigate to the auto schedule page, which will prompt us to select the pod we want to access. Since Jose demonstrated pod 1, I will use pod 2. Once we specify light 1, we are brought to the schedule page for pod 2 light 1. Here, we can now select all the options we want to configure for our schedule entry. Let's say we want to turn the light on for 1 hour at approximately 12 p.m. till 1 p.m. for every day of September. In order to do this, we need to submit 2 entries. For the first entry, we should select on. 12 p.m. for the hour, 0 for the minute, September for the month, all for the day of the month, and all for the day of the week. This way, our light will come on at 12 p.m. for all days in September. When we click Submit, we are taken to a web page on the pods representing Raspberry Pi, which uses the values we have selected to create a cron tab. If you have never heard of cron, basically what cron does is schedule a job for the Raspberry Pi to execute at a later date. The web page we are sent to executes a cron tab command, using the values we gave in order to tell the Raspberry Pi when to turn the light on or off. When we click Submit, we can see that the exact cron job entry given to the Raspberry Pi. We can also see the schedule the Raspberry Pi has right now, which only contains the command we just gave. Now if we go back and schedule it to turn off at 1 p.m. for every day of September, we can see that the schedule has now 2 entries. One to turn the light on at 12 p.m. and another to turn the light off at 1 p.m. Now we have fully automated light for the month of September. We can ensure that our jobs were inputted by going to the Raspberry Pi and using a cron tab command to list all the cron jobs scheduled on this Raspberry Pi. We type a cron tab as the main command, -L to list the jobs, and -U to specify the user data, which the user we are using for the website. We can see that our jobs have been recorded successfully. Now that I have demonstrated the auto scheduling feature, I will now let my colleague Daniel to show how the stats feature works.
Hey guys, Daniel again. I will now show how we are able to log and view the statistics for each light. Every time a light is turned on or off with the on and off scripts, the scripts do 2 things, which were mentioned by Jose before. First, they log an entry into a local CSV file, and second, they turn the light on or off. This local CSV file that gets written to is found in the same directory as the on and off scripts, and the state.txt file which tells us if the light is on or off. We can view everything recorded in this log.csv file by giving the command cat log.csv, and here we can see all the entries given to it over time. First, it gives the date of the entry in the format of year, month, day, hour, minute, second, and then millisecond. After the comma, it then gives us if the light was turned on or off, which is recorded as the state. After the next comma, it gives us the number of the pod, and then finally the number of the light. This is the log file in its raw form, and normally you wouldn't see it like this, but this is how it works behind the scenes. To view the log file for each light from the user interface, we select Stats from the navigation section, select the pod number our light is in, and then select the light number. We are then brought to a page located on the Raspberry Pi which formats the log file into a nice table which we can now view easily from the user interface. We can also easily view the second light's log with a few clicks. This information is useful because we get to see how much our light is being used, and we can then calculate power and efficiency ratings based on these log files. So, that concludes the technical demonstration for Project Green. All of this was built through virtual machines on VMware, but the software can easily be transferred to physical Raspberry Pis, which can then be implemented into any indoor grow room. Thank you for watching, and if you have any questions, please leave them in the comments. You can also ask us questions through our LinkedIns, which you can find in the description below. Thanks again.